Hey kiddos, it's Mrs. Visconti here, and it is time to look into multiplying decimals, which is our new unit for this week. And I want you to take a deep breath and know that multiplying decimals is not very different from multiplying regular whole numbers. There's just one extra step that we're going to throw in. So here we go. Let's go ahead and start with some easy ones. I want us to look at these two equations first. I have 0.8 times 6, or 8/10 times 6. I can also rewrite this based on my last units as 6 times 8/10. So just keep that in mind. Decimals and fractions can be converted into each other. And so if we think about it this way, it doesn't seem so overwhelming. Sometimes when we're doing something new, we can feel like, oh, I'm not sure how to do this, but really it's something we've already done in the past. So this is what we need to know. We just need to know basic math facts. We need to know what 8 times 6 is. Well, 8 times 6 is 48. So I'm going to put my 8 in the first place value column, and then I'm going to multiply across here. So I have 6 times 0, which is 0, and then I'm going to add 4, which is going to give me a 4, which in essence is just straight 48. So it's almost like we just multiplied 8 times 6. Now, the only difference here that we have to keep in mind is we have a decimal. We've multiplied by something that is less than 1. And a simple and quick way to remember that is to jump the decimal. So if there's only one place behind the decimal, that means we are only going to have one place behind the decimal here. So my decimal will go in between the whole number and the leftover piece. So we have 4 and 8/10 as our answer. So if we multiplied here, we would multiply straight across like we do in fractions. 6 times 8 we already know is 48, and we are talking about 48/10. Well, that is an improper fraction. I'm going to take 4/10, which gives me a 4, and that leaves me with an 8/10, which is the same as 4 and 8/10. So technically, you already know how to do this. We're just doing it without a fraction. Instead, we're doing it with a decimal. So let's look at a very similar problem. As you notice, I have the same digits, but I have some different place values. Here, I have a 6 whole number. Nothing new there. But I do have the 8 in the hundredths place and not the tenths place. So I already want you to stop and think very quickly. How is the answer going to be the same? And how is the answer going to be different? So very quickly, I'm going to show you this problem as a fraction. I'm simply saying that we have 6 times 8/100ths. So very similar already. And now as we work through this problem, I asked you really quickly to predict if it's going to what's going to be the same and what's going to be the difference. So right off the bat, I have 6 times 8, which is 48. And then I have 2 zeros. So we can put 1 in their place there because this one's going to have the 4 in it. And we look at that hop. We're looking at where the decimal place is going to land. Well, in our number here, we have 2 places behind the decimal point. So I'm going to go to my answer, and I'm going to hop 2 places to the left towards the whole numbers, and I'm going to place my decimal here. So my answer is 48/100ths. So as you can see, the answers are similar because they both have 4 and 8. The digits are in this number. The difference is where the decimal number is placed. The decimal number here is placed after the 4, leaving it as a fractional piece. There are no whole pieces here. It's 48/100ths. And the same here. I have 48, except the difference is that I have a decimal between the 4 and 8, saying that I have 4 wholes and 8/10. So same with this fractional piece. If we multiplied it like we have been doing with fractions up to this point, we would end up with 48/100ths. I do not have any whole numbers. It is not improper. I can leave it as it is. All right, so this is how we are going to be multiplying decimals. We're going to be doing that little hop. We're going to count the spaces, after, or the place values after the decimal, and that is where our decimal will go in our answer. All right, so here's our next problem. It looks right off the bat a little scary because we've got that decimal point, but I really want you to consider that it's very similar to multiplying two double-digit numbers. We're just going to have to place a decimal in our answer to match it up. So let's look at this as a double digit times double digit number, which we can use the area model, which we're pretty comfortable with. I have past videos of that if you need to be reminded. So we're going to make our area model. We like to call it the 4 square. I'm going to break down 54 into its place value numbers, which is 50 and 4, and then I'm going to break down 63 into a 60 and a 3. Then we are going to do our multiplying around. So I have 6 times 5, which is 30, and then I'm placing 2 zeros, one in the one in the tens and one in the ones place. Then I have 6 times 4, which is 24. And I have a 0. I'm placing it into the ones place because we are multiplying in the tens. So now we're going to go 3 times 5, which is 15, and we have a 0 in the ones place. And then my next one is 3 times 4, which is 12. No zeros in the ones place because we are multiplying a 1-digit times 1-digit number. Now we're going to take all of these numbers, these partial products, and we are going to add them back together because whatever we take apart, we must add back together to get our completed answer. So I have a 2 in the ones place. I have 4, 5, that's 9, and 1 is 10. Then I have a 2, 3, and 4. And then I have a 3. Now you're asking me, Mrs. Visconti, that's all fine and dandy, but we were multiplying it by a decimal. So what do I do now? Well, I'm going to take my red marker here and I'm going to do 2 hops from the outside of the number to the decimal point. That means there are 2 places after the decimal point. That means I'm going to take this decimal and I'm going to hop it 2 places in, which gives us the answer 34 and 2/100. So let's go ahead and look at it in the algorithm method. We're going to go ahead and multiply starting in the ones place. So we have 4 times 3, which is 12. We're going to carry that 1. The 1 is in the tens place, and so we're going to put it above the tens place. I'm multiplying 5 times 3, which is 15, plus that 1 gives us a 16. Now to move on to the tens place, I place a 0 in the ones because we're not multiplying there anymore, and I have 6 times 4, which is 24. I'm going to cross that 1 out because we've already used it. I'm going to place a 2 above, and then I have 6 times 5, which is 30. Plus that 2, which is 32. Now I have a 0 here. I could place a 0 here for 3 times 0 and then place a 0 here for 6 times 0, but a 0 at the beginning of a whole number is really not doing much for us, but we can write it there so you can see it. All right, so now we do addition. We have a 2, we have 10, 2, 3, and 4, and then we have our 3. Now we're not done. We did not get a number up into the thousands. Instead, we have our 2 hops from the end and showing 2 places after the decimal. So we need to place 2 places after this decimal too. So there's 1 and 2. We have hop 1 and 2 with our decimal at 34 and 200. So our answers are the same. 2 different methods, got the same answer. So our next problem is going to be a 2-digit times a 3-digit. And we can do this one also as an area model and also with an algorithm if we just consider our 2 numbers to have 2 digits broken down and 3 digits broken down. So I'm going to break my box into 6, 3 across the top and bottom, and 2 down the sides. I have a 60 and a 6. And then across the top, we're going to break it into its place values. We have 200 times 10 times 6. Now we're going to go around and multiply each side, and whatever we break apart, we will add back together. So 6 times 2 is 12. And I have 3 zeros, 1 in the hundreds, 1 in the tens, and 1 in the ones place. Then I have a 6 times 1, which gives me a 6. And then I have a 0 in the tens, a 0 in the ones. And then here I simply have a 6 times 6 with a 0 in the ones place. Now I move down to the next row. I have 6 times 2 again, which is 12. This time I only have 2 zeros, 1 in the tens and 1 in the ones place. And then I have a 6 times 10, which is 60, and then 6 times 6, which is 36. So now we're going to add them back together. I like to organize from greatest down to least. So we're going to start here with 1200, and then we're going, or 12,000, and then 1200, 600, 360, 60, and then 36. And now we add. So I'm going to start with the ones. We have a 6, and then 6 plus 6, because we're adding now, not multiplying. It's 6 plus 6 is 12, and then 13, 14, 15. Now I'm moving into the hundreds place, so I have 6, 7, 8, 9, 10, 11, 12. Carry my 1. I have 1, 2, 3, and 4. I have nothing to add to the 1, so I bring it down. Now, just like the last problem, you're thinking, Mrs. Visconti, we did not multiply it by whole numbers. There's a decimal point. What do? Well, I have 2 place values after the decimal point, so I'm going to do my hop. And so I'm going to do the same thing here. I'm going to hop my 2 place values, and I'm going to place a decimal. So our answer is 124 and 56 hundredths. So if you would like to see that done as an algorithm, here we go. 6 times 6 is 36. I carry my 3. Again, 6 times 6 is 36, but this time we're adding a 37, 38, 39. And I have to carry my 3 and place it over the 0. 6 times 0 is 0, and then we have our 3 because we're adding 3 to that 0. All right, we drop a 0 into the ones place because now we're multiplying in the tens place. So 10 times 6, or 6 times 10, or 6 times 1 is 6. 1 times 6 is 6. And you don't need these anymore because they were part of the first multiplication. So 1 times 0 is 0. I don't need the 0 at the front, but I'll put it there anyway. I'm now multiplying in the hundreds place, so I need to have 2 placeholders, 1 in the 1, 1 in the tens, and I go back in and multiply again. So I have 2 times 6 is 12. Carry that 1. Now see, we're glad we crossed that 3 out because when we multiply 2 times 6 to get 12, and we get that 1, we don't want to add the 3, we want to add the 1. 2 times 0 is 0 with a 1 to add in, and our multiplication is done. We are now ready to add. So I have 6, I have 9, 10, 11, 12, 13, 14, 15. I have 6, 7, 8, 9, 10, 11, 12. I carry my 1. I now have 4, and then I have a 1. Notice my answers are almost the same. They are now the same once we add our hop. And we're hopping 2 places because there were 2 places behind the decimal point in our multiplication factor. All right, so there we go. This is how you do a 2-digit times 3-digit. You can do it as an area model or as an algorithm. So we've done some basic multiplication, but now I would like to show you how we can take a number like this and break it down using some of our properties. So I have a 2 times a 2/10. So what I'm going to do is I'm going to break this down. And I'm going to say 2 times. This number here can be broken out and shown as a 2 times 0 and 1/10. Because 2 times 1/10 is going to be 2/10. So I'm breaking out that whole number to easily work through the problem. So when I come to this, I have 4 times 1/10. And then for my end here, I know that when I multiply anything times 1, I'm getting that number. So I have a 4. But I also notice there is a hop in this number. I have to hop once. So that means my decimal will actually go here because there's always an invisible decimal behind a whole number. And our answer ends up being 0.4. And I know this works because 4 times 1 will equal 4. And then I notice that I'm not multiplying by a whole number, I'm multiplying by a partial, in this case a decimal, so I have to have a decimal in that place. So that is a single digit times a number in the tenths. Let's take a look at another problem. So we get a little bit bigger. Now we have a double digit times a number in the hundredths. Now don't get worried. Let's go ahead and break what these numbers mean. So break down what these numbers mean. This is a 50, so that means a 5 times a 10. It's the same thing. And then let's look at this number. As we did last time, we're going to look at what is this digit, and that is 7. So we have, in essence, said 7 times 1/100th. Now I have an easier problem to work on because I can very easily multiply these three numbers together. So if I have 5 times 7, that's 35. 35 times 10 is 350. I can even show it with the bracket showing that that's what that works out to. And then we're going to multiply times a 1/100th. And that's super easy. It just works down to mental math now because I know that 350 times 1 is going to be 350. Now when I do my hop and I add that decimal place in there, I start where my invisible decimal is, the one that's holding the place in case there are partials. And I'm going to hop twice and place my decimal here. So my answer ends up being $3.50 or 3 50/100ths or 3 5/10. All right. So that is one more method or one more break apart. And this is another one. Let's do this last one. I notice I've got a lot more zeros. I'm in a bigger place value. But just like the others, we're going to simply break everything into pieces and use the easier pieces first and then bring them back together. So I have 5 times 100. And then we already know that anything times 1 is itself. So I'm going to take out that 8 and I'm going to multiply it by a 1/100th. So let's do the easy stuff. Let's do 5 times 8. We're going to multiply these together. 5 times 8 is 40. And then we're going to put it into the 100. We're going to multiply it by 100 there. So we have 2 more zeros, 1 in the 10 and 1 in the ones, which brings us up to 4,000. And all we have left now is to multiply 4,000 times 1/100th. So I know that 4,000 times 1 is 4,000, but I have that decimal hop, so let's hop it over. 1, 2. And that means my decimal will come right there in this number, which means we end up with 40 with 2 zeros in the partial places in the tenths and the hundredths, or just simply 40. All right, kiddos, I hope that this helps, and I hope that you are getting your Think Central work done, and I will see you at another time.